Hello, in this video we are going to see the tree traversal methods. So let's start. First of all, what is the meaning of the tree traversal? It means visiting all the nodes of the tree in the specific order. And what is the purpose of this? If I want to access any element, if I want to search a specific element, or if I want to do some processing onto the each and every element, so through these techniques I will get to know that I have processed that particular node exactly one time. So what are the different techniques are available? In this video we are going to cover the three techniques: pre-order, in-order and post-order. So let's start with the pre-order. Pre-order means you have to process the root first. After that you can go to the left side and you can process all the elements which are present to the left side, and after that you can process the right side of that root. In case of the tree, you cannot directly jump to any element of the tree. Always you have to start from the root node. So I will come to this root node, and here in case of the pre-order you have to visit or process the root first. Then you are allowed to go to the left side. Then after that you can go to the right side of this node A. So first of all we will process the A. It means I will say that I have printed the A. After that you can go to the left side of the A. So we will go to the left side, and in the left side again this B is a root of this particular subtree. So in case of the pre-order, first visit the root, then you can go to the left side of the B. So print the B, and after that move towards the left side, not to the right. First of all move to the left side. So we will come here, and in case of the D, D is also one of the roots, so we will printed the D. There is no any element to the left, so we will not go to the left, as well as there is no any element to the right, so we will not go to the right side. Now when I come to the B, we have already processed the B, and as well as we have already processed the left part of the B. So it's allowed to go to the right side of the B now. So we will go to the right side. Now there is a one node E. So we will process that node, or we can say we have printed that node E. And after that we can go to the left side of the E, but there is no any element to the left, as well as there is no any element to the right. So we will come here for the root, and in this case for the A, we have visited the A as well as all left part of the A. So it's allowed to go to the right side of the A. So we will go to the right side of the A. Now for this right side, this C is again a, you can say, root of this particular subtree. So what we will do, we will print the C, or we can say we will process the C, and after that we can move towards the left side of the C according to the pre-order. So when I go to the left side, again this F is one of the root, and so I will print the F, and I will try to move towards the left side, but there is no any element to the left, as well as there is no any element to the right. So I will come back to this C, and in case of the C is already printed, means the root is already printed, as well as we have visited all the nodes to the left of the C. So it's allowed to go to the right side of the C. So we will go to the right side, and for the G we will process the G as it is one of the root, and I will try to move towards the left side, but there is no any element to the left, as well as no element to the right. So this is the pre-order traversal of the given tree. I will take one more example for the pre-order. As I said, you have to process the root first, left, then right. So in this tree, this is a 8 is a root. So we will first visit the 8. After that, we can move towards the left side of the 8. So when I go to the left side, 3 is again the root of this particular subtree. So we will visit the 3, or we can say process the 3, then go to the left side of the 3. And 1, again 1 is one of the root, so we will print the 1. After that there is no any element to the left, as well as no element to the right. So again I will come back to the 3. In case of the 3 is already printed, as well as we have visited or processed all the elements which are present to the left side of the 3. So it's allowed to go to the right side of the 3. So we will go to the right side to process the right elements. Now we will process the 6. So 6 will be printed, and I will after that try to move towards the left side, but there is no element to the left, as well as no element to the right. So we will go to 8. Now for the 8, it is already processed, you can see, and as well as we have processed all the left part of the A, so it's allowed to go to the right side of the A. So we will come here to the right side. Now this is also one of the root of the subtree, so we will print the 10. After that we will move towards the left side of the 10. But there is no any element to the left, so we will allow to go to the right side of the 10. Now there is only one element, so we will come to that element. Now in case of the 14, first of all we will process the 14. After that I will try to move towards the left side, but there is no any element. So I will try to move towards the right, but there is no any element. So this is a pre-order of the given tree. But now how can I implement this pre-order in the C language? I will show you how to implement this pre-order with the help of recursive function. Recursive function means the function which call itself. If you observe that the name of the function is a pre-order, and again from the pre-order function you are calling the same function. So this pre-order is a recursive function. For this pre-order function, first of all we will send the root of address of the root of this tree, means we will send the address of the 8 to this pre-order function. Now here it will check if it is empty, then they will return from this function. Otherwise what they will do in case of the pre-order, first is you have to visit the root. So we have to print the temp data, and after that what I said is I will print the 8, and after that I said that now visit this subtree which is present to the left side of the 8, visit that subtree in the pre-order. So we are again calling to this function pre-order temp left, means go to the left side and again visit that left side in the pre-order format. Visit the right side as well in the pre-order format. So we can implement this pre-order traversal technique in the C language. Next traversal technique is the Inorder. In case of the Inorder, first we have to process all the elements which are present to the left. After that you can process the root, and then we can process all the elements which are present to the right side. So let's start. This is a given tree, and as I said you have to always start from the root node of your tree, but you cannot process the 8 as you are in the in-order traversal of the tree. So what they said that before processing the 8, go to the process all the elements which are present to the left side of the 8. So we will move towards the left side of the 8. Now for the 3 as well, what they said that first process all the elements which are present to the left, then only you can process this root of the subtree. So we will move towards the next point. Now for the 1, what they said that you can go to the left, then only you can visit the A, but there is no any element to the left side of the 1, so we will print the 1, or we can say we will process the 1. After that we can go to the right side of the 1, but there is no any element to the right side. So we will come for the 3. In case of the 3, what we have done, we have processed all the elements which are present to the left side of the 3. Now it is allowed to print or process the 3, so we will print the 3. After that we will move towards the right side of the 3. Now next we will come to this node 6. For the 6 we have to process first left part. There is no any element to the left side of the 6, so we will process the 6 here, and after that we will go to the right, but there is no any element to the right side. Now we will jump to the 8. For the 8, what we have done, we have processed all the left part of the 8, so it's allowed to print or process the 8 now. So we will print the 8. After that we can go to the right side of the 8. First of all you have to go to the left side, but there is no any element to the left of the 10, so we can process the 10 here. So 10 will be printed. After that you can move towards the right side of the 10. Now here in the right side there is only one element, 14. There is no any element to the left side of the 14, so we will print the 14, and right is also null. This is the in-order traversal of the given tree. Now how can I implement this in-order into the C language? Same like how we have implemented the pre-order with the help of recursive function. And initially you have to pass the root of this tree to the in-order. If this is temp will become a null, that time it will come out of this recursive function. Otherwise, what we have written, what is the sequence here? First you have to process the left part. So we will write down, call the inorder or visit all the elements in the inorder fashion of the temp left, means whatever present to the left part of the 8, process all the elements into the inorder fashion. After that, once you finish with the left part, then you are allowed to print or process the temp data. It means they will print the 8. And after that, they said that you can go to the right side of this 8 and visit all the elements in the inorder fashion. So here printf statement will be in the middle of the two recursive statement. First go to the left side in the inorder fashion, then print the data, and after that go to the right side in the inorder fashion. Like that you can implement the inorder traversal into the C language. Write your answer in the comment what will be the inorder traversal of this tree. And last traversal technique is a post order. In case of the post order, first we will process all the left part of the tree. After that, all the elements which are present to the right, and then only you can process the root of your tree. This will be the sequence of the post order. So when I start from the root, in case of the 8, we cannot directly process the 8, or you can say print the 8. First of all, you have to print all the elements which are present to the left of the 8. So I will come to this next element. Here as well, you cannot directly print the 3. First of all, you have to go to the left, then right, then only you can print the 3. So I will go to the left part. Now for the 1, there is no any element to the left as well as no element to the right. So you can print or process the 1 in this case. After that, I will come for the 3. In case of the 3, we have visited or printed all the elements which are present to the left part. Now you have to move towards the right side of the 3. So we will move towards the right side. For the 6, there is no any element to the left as well as right. So we can print or process the 6. Now again we will come to the 3. In case of the 3, we have done with all the left part as well as all the elements which are present to the right. Now you are allowed to print or process the 3. After that, we will come to the 8. For the 8, we have done with all the left part. Now you cannot process the 8 as the right part is remaining. So we will move towards the right part. In the right part, there is one element 10. So first of all, we have to move towards the left side of the 10, but there is no any element. So we will move towards the right side. In case of the right side, there is only one element. So we will visit the 14. Because there is no any element for the left and right of the 14, so you can directly visit the 14. Now we will again come to the 10. For the 10, all means there is no any element to the left and we have visited the right part. So it's allowed to print the 10 now or process the 10 now. So this is the post order of the given subtree. Now how we can implement this post order into the C language? Same way, post order is the name of the function and we are passing the root of this tree to this function. It means we will pass the address of the 8 to this function and it will be copied into the temp variable. After that, this when temp will become a null, that time I will come out of this recursive function. Otherwise, what we are saying, just visit all the left part into the post order fashion. Same way, all right part into the post order fashion, and after that print or process that temp data. This is the way we can implement the post order into the C language. Calculate the post order of this given tree and write your answer in the comment. I just explain you the code of the preorder, inorder and post order. Now let's see execution of these functions. Here I have written the same code. This is a inorder function. After that, this is a preorder function and this one is a post order function. So let's see the execution of this code. I have already uploaded the code about how I can add the element, how can I delete the element in case of the binary search tree. You can refer that video to understand how to add and delete the element from the binary search tree. Now we will see how we can display the elements of the binary search tree. First of all, we will add some element into the tree. Consider I said that I want to add the 34. Now this will become a root of your tree as there is no any element. After that again I have given the choice as a 1, and consider I will add the 23. Now this will be added to the left side of the 34. After that again I said that I want to add the element. Now I said that I want to add the value 45. Now this will be added to the right side of your 34, that is a root of your tree. Now I will call to the display function. Now you are able to see they have displayed the in order. This is the in order, this one is a post order, and this one is a pre-order of your tree. And always remember that in order of the binary search tree is always sorted. If you observe that 23, then 34 and 45, this is the sorted data. So in order of the binary search tree is always sorted. I hope you are able to I hope you have understand the in-order, pre-order and post-order traversal of the binary search tree. Thanks for watching my video. Thank you.